So the notes here says using the triangles in the pictures in the previous page, square the two side lengths and add. And what do you notice about the sum? Well, we kind of tried it before and it way up here, and it looked like when we square the side lengths, we end up with the square, the area of the diagonal square. Okay, and let's see if this works here. So we have this triangle, the right triangle here, and this right triangle, I just drawn it in red here. And let's see what happens when I take the squares of each of the side lengths. So this is a length of 4. So if I draw the square here, I get 16 squares here. And this is a length of 8. So if I draw my side length of 8, so it looks like there's my square here. It's an 8 by 8 square. So I end up with 64 squares in here. I'm just going to move this over because it's kind of distracting. Okay, so I have 64 squares here. And when I look at these two squares, it seems to, well, these two squares seem to be able to fit into this square here. And the numbers seem to work out. 16 plus 64 gives us 80 squares. And we ended up calculating 80 squares in here. And let's kind of see if this works for these other ones here. So, well, let's try it for these ones here. So what seems to be happening, first of all, we need to break it up into those squares and rectangles, or squares and triangles here. So I'm going to do that first. So I'm going to break it up into my squares and triangles. Okay. And the triangle that we are dealing with is really this one here, right? It's the same as all these 4 triangles here. And so what seems to be happening, and I don't know if this is necessarily true. Maybe, and I don't have the squares here, but although that's side length 4, so I know that's 16. I have 1, 2, 3, 4. That's 7 squares. So 3, 4, 5, 6, 7. Okay, so 7 by 7 square here. So this is 49 squares. And what seems like is happening is this square and this square together can fit inside that square. It's hard to say because it's one diagonal, but we can actually just calculate the area of that square. So here we have 65 squares between these two squares. And in this one diagonal square, we have 9 here. This is 4 by 7. So 4 times 7 divided by 2 is 14. We have 14 here, 14 here, 14 here. Okay, so if I add those all up, 14 plus 14 plus 14 plus 14 is 56. So the total area works out to be 65 squares. And it seems that it's working. Now maybe we just got lucky all these times, but when we look at this relationship, it seems reasonable that this square and this square kind of fit into that square. Now it's hard to see, but our numbers seem to be working out as well. So maybe there's something to this. Okay, so that wasn't what we're trying to figure out the side length of that side. So to find the side length, we're going to end up square rooting. So let's make sure we add up this, that we actually answer the question here. Okay, so the side length here is approximately, well, it is exactly square root 65. The side length that gives us a square area 65. And as a decimal, it's approximately 8.06. Okay, because it's just a little bit bigger than 8. Okay, so this is very useful to know because that helps us. This may be a way we can help us calculate the area. So we're not too sure about this yet, but it seems like there's a bunch of triangles that it works for. So let's maybe draw this triangle out here and see if it's going to work out here as well. So we got 4 by 4, so that's 16. 1, 2, 3, 4, 5, 6. So that's going to be a 6 by 6. Okay, so 6 by 6 is 36. So we should have 52 if this is actually working. Okay, so let's chop up this square into nice shapes here. Okay, so there's a 4 by 4 and 4 times looks like 6 divided by 2 is 12. These are all 12. Okay, so that's going to be 48 plus 4 is equal to 52. So the total area here is 52 as well. Okay, so it seems like there may be a relationship here. Now, we've got no proof of this, by the way, but it seems like this is holding true, and it doesn't seem unreasonable either, because these two areas seem to again fit into that area. So the total area is 52 squares. Okay, and then really what we're trying to find out is the side length. The side length here is going to be square root 52, which is approximately just a little bit more than 7. So we're going to go second square root 52, and we get 7.21. Okay, and that seems about reasonable. That, okay, if we were to kind of look at this, that's 7.21. Yeah, that looks like it's working. So to find out this diagonal length here, I really need the square. So, I need to kind of get rid of this. I need the square. So these squares are kind of hard to draw, but I think I can do it. It's going to be, this triangle is going to be really useful. So it's 1 down, 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to go 1 over 1, 2, 3, 4, 5, 6, 7, 8. That's going to be one corner. Okay, that looks like a 90-degree line. 1, 2, 3, 4, 5, 6, 7, 8, and 1 down. That looks like the other corner here. Okay, so I'm just going to erase this here because this is a little bit distracting. Okay, and then connect those. Yeah, that's all going to be 90 degrees in there. And I need those triangles to be able to calculate this area. Okay, so I'm going to need these triangles. So I'm drawing in these triangles here. Okay, these are 1 by 8 triangles. So it's 4, 4, 4, 4. And this is 49 in here. So that's 4, 4, 4, 4. So 16, 32. I get 81. Hold on here. So that's going to be 49. That's going to be 16 plus 49. That's going to be 65. So I'm going to have 65 squares here. So the area equals 65 squares. So this side length works out to be the square root of 65, which is just a little bit longer than 8. In fact, these two lines, although they're at different angles, they're actually the same length. Okay, because they're going to they both have the same size square, and so they both are about 8.06 units long. Okay, so they'll clean that up a bit. 65 units squared. Okay, and again for this one here, we're going to use this triangle. And again, this triangle is really useful because this triangle allows us to work out how I'm going to find the corners to make the square here, because I need the square to find out the length of that line. So I have 1, 2, 3, 4, 5, 6. Okay, so that's 6 by 1, 2, 3, 4, 5, 6, 7, 8. So 6 by 8. So I'm going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so my corner's in there. Okay, it's kind of overlapping. Okay, so I'm going to get rid of this again. Okay, but boy, those squares seem really useful. So it's hard to make this diagonal square. So I wonder if I can use those squares. I wonder if I can use those squares somehow to make it a little bit easier for myself. Okay, so there's my diagonal square. Okay, I'm going to draw in my lines here, and again, those corners are found by using these dimensions, 6 and 8. So I got to go, so this is 6, so it's got to go 6 the other way. So this is 6 vertical, so I got to go 6 horizontal, 8 vertical. 8 vertical switches to 8 horizontal, 6 vertical, and that allows me to get the 4 corners of this triangle, of this diagonal square. Once I get the 4 corners of the diagonal square, I can make my nice right triangles, which is the same as the yellow one here. This is going to be 6 by 8, so 6 times 8 divided by 2. Okay, this is a 2 by 2 square, so there's exactly 100 squares in there. Well, that's a perfect square. So the total area is 100 squares. Okay, so the side length, when I work out the side length here, so side length is square root of 100, which is 10 units long. Okay, so this is, I've got the nice shape there. I've got my square, and I find that by using that triangle, but 6 by 8 triangle to get the corners. If I switch the X and Y's, I'm going to get that 90 degree in there. If I use the same dimensions here, I'm going to get the exact same length line, so this has to be a square. So the other thing was, though, we did talk about the squares from the straight lines, and this diagonal square was a little bit harder to draw than these squares. So this is an 8 centimeter, 8 units, so 1, 2, 3, 4, 5, 6, 7, 8. Well, this is a little bit easier square to draw because it's going to be along there. And that's going to be 64 squares. This is going to be 1, 2, 3, 4, 5, 6. And this is going to be 36 squares. And again, these two squares seem to add up to that one. So maybe this might be an easier way to get this area, although we still need to be able to draw these squares in diagonally and find the corners and make the perfect right angles here. This is going to maybe help me out do the calculation. So does this help, when I draw the square from the line segments given, so the square from the side, does it help to use the right triangle? Yeah, definitely. If I want to use this, if I want to draw the square in here, I need to use that right triangle. So definitely yes. Yes, not only that, it seems like those squares seem to have something to do with that diagonal square. And so on the grid provided, draw a square with an area of 25 plus 64 equals 89 square units. Yeah, that seems like a random question, but one thing I do notice is that this is a perfect square, and this is a square, and I need to draw 89 squares, a perfect square with 89. Well, I don't know how that's going to work, because I have a 25 square, so that's easy. 25 squares is going to be a 5 by 5 square. So there's a 25 square, and I know a 64 square is also a square, and I need to figure out how to draw a square with 89 squares. So not quite sure, but maybe if I want to just draw a 8 square, so 2, 4, 6, 8. So here's an 8 square, 4, 8. So that's 64 squares here. So I need to be able to draw 89 squares. Obviously 89 squares I can't draw like this because it's not a whole length. So it's going to be one of these diagonal squares. So I need a diagonal square with 89 squares in it. I need to kind of figure out how am I going to make that happen. So if I'm using maybe this property, I wonder if this property can help me out. Okay, and I'm going to leave it at that. And I want you to figure that out.